For number 19, we're given this pair of parametric equations, and the first thing that we want to do is we want to eliminate the parameter to obtain an equation in x and y. So what we're going to do here is we are going to use this identity sine squared of theta plus cosine squared of theta is equal to 1 to eliminate the parameter. So we have that x is going to be equal to 3 cosine of t, and y is going to be equal to 3 sine of t. So let's square both sides. I have x squared is equal to 9 cosine squared of t, and y squared is going to be equal to 9 sine squared t. And sine squared t. And now we're just going to add these two equations. So adding the left-hand side gives us x squared plus y squared is equal to the sum of the right-hand side. So it's going to be 9 cosine squared of t plus 9 sine squared of t. And now we're just going to factor out this 9. So that would be 9 times cosine squared of t plus sine squared of t. And once we're here, we can see that this matches our identity perfectly. So that's just 1. So the result of our equation is x squared plus y squared is equal to 9. And now we know what this looks like, right? Because this is just the equation of a circle that's centered at the origin with radius 3. So 1, 2, 3, it would go something like this. So this means that a circle with radius 3 centered at the origin. Okay. However, we are not done here because we do need to also put a restriction here for this parameter, right? Because t was between pi and 2 pi, which meant that we're beginning over here, we're at pi, and then we're going around all the way to 2 pi. So it's not the full circle, it's really the semicircle that begins at the outer edge on the left and then ends at the outer edge on the right. So now what we just need to do here is once we've understood that this is a circle, we just need to put the starting point and the ending point. So it begins at, so we've drawn this here and we can understand it, but just to show you guys how to actually calculate this, the lower boundary of our parameter is pi. So we're going to plug in pi here for x and y. So x is going to be equal to 3 times cosine of pi, and cosine of pi is just minus 1. So x is equal to minus 1 times 3, minus 3. And y is going to be equal to 3 times sine of pi. Sine of pi is 0, so y is equal to 0. So at the beginning of our curve, when the parameter t is pi, we're really beginning at the point x is equal to minus 3 and y is equal to 0. So it begins at the point minus 3 comma 0 and ends at, so now let's plug in 2 pi here into our equation because that's the upper boundary. So we have that x is going to be equal to 3 times cosine of 2 pi. Cosine of 2 pi is just 1, so x is 3 times 1, 3. And y, once more, is going to be 3 times sine of 2 pi, which once more is just 0. 3 times 0 is 0. So it ends at the point 3 comma 0, which as we expect is this point here. So that is it for problem number 19.